Have a look at this old photograph of an unusual suspended monorail powered by literal airplane propellers. What you're seeing here is the Railplane, a high-speed vehicle that would have moved passengers across great distances at double the speed of most modern trains today. And although this brilliant concept was demonstrated with great success, its wider implementation was crushed by crooked businessmen whose comparatively impotent ideas would have vanished from the face of the earth had they been challenged by this cutting-edge technology. Even so, traces of the Railplane exist in modern times, and today we uncover that forgotten past. So join me as we discover the story of the lost Railplane. I'm your host Ryan Socash, and you're watching It's History. The locomotive was a technological innovation that completely changed the world. It allowed us to carry goods and people overland quickly, and from the onset, inventors had been looking for ways to optimize the concept further, resulting in some very bizarre ideas. And once the industry realized it would face competition from other forms of travel, such as planes and trucks, the railroads sought ways to rival high speeds, while at the same time maintaining safety and competitiveness. In fact, there was so much experimentation that over 100 years ago, people thought the 21st century would be dominated by high-speed monorail, a safe, fast, and reliable means of transportation. However, if we're being honest here, in the scale of history, there really haven't been that many breakthroughs. Monorails just really never caught on the way that people had hoped, but it wasn't for a lack of trying. Even if many inventors worked hard during the first half of the 20th century to make it a reality. One of the most exciting experiments was George Bennie's Railplane, an elevated monorail that hung from an overhead rail but moved using front and rear propellers. The idea of using propellers on trains was not unique. In fact, contemporary examples of this technology existed in both Germany and Russia long before Bennie's Railplane existed. Expressly, German Herr Paul Krukenberg fitted an air scrap propeller to a passenger coach in 1930. Powered by a 600 horsepower engine, the propeller moved the coach down a stretch of prepared track at over 140 miles per hour. However, Krukenberg didn't take any chances and had the coach run along a straight track with no curves. For had it had curves, it would have flown off the rails. The results of these experiments also encouraged inventors to study the problems with high-speed rail, demonstrating that the problem was confined to the tracks, not the locomotives. Realizing these limitations led inventors to develop brand new ideas that differed from conventional railways. The idea of suspension rail also wasn't unique. In fact, it was one of the ways engineers sought to build monorails suspended by affixed tracks as opposed to the cable used by aerial trams. The first passenger-carrying suspension railway was used as early as 1825 in the town of Hertfordshire. Patented 4 years earlier by Henry Robinson Palmer, this horse-drawn carriage was built to carry bricks, but as an opening stunt, it carried passengers instead. It took another 50 years before a steam-powered monorail was demonstrated at the U.S. Centennial Exposition. This variation was an ornately designed double-decker vehicle designed by General Leroy Stone, but it was more of a fairground attraction than an attempt at revitalizing transportation. Then, a decade later, the Enos Electric Railway, an electric-powered monorail, was demonstrated at the Draft Electric Company in Greenville, New Jersey. It was composed of lightweight steel wagons suspended from an elevated open steel frame, but was never expanded. The design of its rail frame likely influenced civil engineer Eugene Langdon of Cologne, Germany, inventor of the famous Schwebebahn suspension railway, still in use today. Built in 1901, this monorail has run along the Wuppertal River for over a century, surviving 2 world wars. And as amazing as these advancements were, one man begged the question, what would happen if you were to combine a monorail with an airplane? George Bennie was born on August the 29th, 1892 in Aldhouse near Glasgow, Scotland. He was born to a wealthy family and was the second of 4 children to John Bennie, the co-owner of the Star Engine Works Engineering Company, and his second wife, Elizabeth Glisby. George Bennie served in the Army Service Corps during World War I as a private with the service number RTS 3794 in the remount section. He was shipped out to France on August the 20th, 1914, where he was a regular and ultimately was awarded the 1914 Star for his service. While in France, the remount section was responsible for purchasing and handling horses and mules, which moved several times and was comprised of depots of over 3,000 animals. On March the 5th, 1916, Bennie transferred to the Royal Flying Corps as an air mechanic with the service number 26321. And critical to the story of the railplane, this is where Bennie learned about aerospace engineering. In fact, when the RFC became the Royal Air Force in April of 1918, he was classified as a fighter. After the war ended, Bennie began to focus more on his interests. He always had been intrigued by rail travel, and in 1920, he examined an early steam engine, deciding that trains would be more efficient if they traded coal power for propellers. And a year later, Bennie applied for a patent for his new railplane system. He started on development immediately as news of his invention began to spread. The problem Bennie wanted to solve was that passenger trains were often bogged down by slow-moving freight. He aimed to provide rapid transit for passengers, mail, and other light, non-bulky freight through his railplane. Bennie envisioned it as a combination of an airplane and a locomotive, an aircraft that flew on rails. He described this concept in his system of aerial transport patent as a propeller-driven carriage suspended by an upper rail and guided by a lower rail. With only a single bogie above, trucks with 4 to 6 wheels would support the weight of the carriage at rest and slow speeds. In motion, wing airfoils at either end of the car would lift the vehicle off the tracks, increasing its efficiency by reducing friction. This would allow gradients. In other words, any rising or falling in the direction of the movement along the track. These gradients could be as steep as 1 in 25 or 4%, to be easily overcome due to no wheel adhesion from the car's weight being necessary to drive it forward. Heavy and expensive earthworks, bridges, tunnels, and dams could be eliminated thanks to this great technology. For corners, a bogie on the lower rail would guide the car to prevent swaying, waving away any need for barriers, and hills that tilt ordinary trains towards the inside of the curve to avoid derailing. This construction of bogies made it impossible for the railplane to be derailed. This vehicle would be capable of high speeds and operate independently from standard rail transportation. The propellers driving the railplane could be powered by internal combustion engines or electric motors powered via an electrified rail. So with the help of consultant engineer Hugh Fraser, Bennie's dream became a reality. After 9 hard years of work, a prototype railplane and track was erected over a disused London and North Eastern Railway siding, leading to the Burnbrae Dye Works near Glasgow. Teesside Bridge and Engineering Company built the elevated tracks, which were a lattice box girder construction with vertical clearance of 16 feet above the railway, the standard bridge clearance at the time. It was 425 feet long, with each of its 5 spans and the arches between its supports being 80 feet long. This allowed for a minimal amount of ground to be occupied. Additionally, these types of tracks could also incorporate utilities, such as telephone and electricity. The railplane test car was made by William Beardmore and Company, and the framework was constructed with a lightweight aluminum copper alloy and a steel keel covered in an aluminum skin. In total, the railplane weighed 12,000 pounds or 6 tons, was 8 feet in diameter, and was 52 feet long, complete with 9-foot-long 4-bladed air screw propellers on both ends of the carriages to move it along the line. Electric motors were used and received their power through the rail, providing a continuous 60 horsepower at 1,200 RPM. But it should be pointed out that they were also capable of short bursts of 240 horsepower for up to 30 seconds. Braking was handled by reversing the propeller's rotation and having the bogies grip the rails. 2 wheels in the engineer's cab had complete control of the car and were outfitted with both hand and automatic braking power. However, the test car differed from the patent, lacking airfoils to lift the railplane and adding a second bogie to suspend the vehicle. The bogies also had rubber inserts and laminated springs, somewhat similar to the leaf springs used in car suspension. To reduce noise and vibration throughout the ride, these springs also controlled how hard the bogies gripped the rails and could be adjusted to suit the service conditions. The deceleration rate, for example, could be set equal to that of a London omnibus, which was about 4 times stronger than the deceleration allowed in railways. Since the railplane doesn't rely on adhesion between the wheels and the rails to drive itself forward, its weight could be reduced to a minimum. This would reduce the effects of side winds and swaying during turns at high speeds. All this caused the track resistance to be very small. While the test car may have weighed 6 tons, someone could quickly and easily push it along the track with just a single hand, as the total track resistance was only 48 pounds. No expense was spared for the interior of the car. The entrance was adorned with stained glass sliding doors in the style of Rennie Mackintosh, and the 24-seat passenger area was outfitted with Waring and Gillow armchairs. The decor consisted of thick carpets, table lamps, and curtained windows. The carriage was white and streamlined in a cigar shape for minimal air resistance, causing journalists to liken it to that of a blimp or zeppelin. Throughout construction, George Bennie kept an eye on the track and the train, ensuring they were built to his specifications. In all, the car looked like a smooth, luxurious pod, befitting to its growing reputation as the mode of travel from the future. On July the 8th, 1930, the railplane line was officially opened to the press, select members of the public, and potential clients. Bennie claimed it was the fastest, safest, and cheapest land transportation, attracting people worldwide. Passengers entered the railplane by way of a tiny elevated station platform, and although the rides were short, they efficiently demonstrated the service that a completed rail line would provide. It was noted that the ride was smooth in acceleration and very comfortable. And surprisingly, there was very little noise from the propellers except at the start. Without any additional noise from the turning wheels or whistling steam engines and the minimal air disturbance inside the car itself, the railplane was quieter than a luxury train. In fact, many recalled that they couldn't even tell the railplane was moving unless they looked outside of the vehicle's window. Bennie gave many demonstrations while interest was running at an all-time high. Overall, the response was positive, and most were impressed by its potential as a means of safe and rapid transportation. Many companies showed interest in Bennie's idea, especially since he planned to build a railroad track above existing lines, minimizing his invention's cost, land use, and environmental impact. The only land needed would be the comparatively small concrete pads for the track frame support. Quick passenger trains would fly through the air above, while slow and heavy goods would travel on the freight trains below. Furthermore, the same railplane cars could be used for short suburban trips or long non-stop runs with no limit on the rate of acceleration except for the comfort of the passengers and crew. While the track wasn't long enough to test for it, Bennie believed that his railplane cars could travel at speeds as high as 120 miles per hour, and with a few tweaks, they could go far beyond that with better engines and propellers. Each vehicle could also carry a maximum of 48 people, although the prototype had seats for less. When making the railplane car into a complete train, cars could be coupled with a device that revolves around the propeller shafts. Therefore, a single engineer in the lead railplane would control all of the propellers. This would allow each of the cars to be driven by its propellers, allowing maximum efficiency and not needing to have a massive crew. It had the speed of air travel with none of the problems associated. Southern Railways also expressed interest in a London to Croydon airport link, as well as a line between Edinburgh and Glasgow. There were even plans to create a high-speed link between London and Paris with a seaplane that carried the passengers across the English Channel. The railplane would be a game changer, as these trips would be completed in nearly half the time they take today. But those plans would never come to be. Despite interest from around the globe, Bennie couldn't get the financial backing needed to develop his revolutionary transport system. And it also needs to be considered that if it weren't for the worst economic crisis in modern history, the Great Depression, the railplane likely would have been made. You see, this crisis affected the United States and the world at large due to the world's economy being linked to the gold standard. It didn't help that many European countries relied on American financing after World War I. But with World War II on the horizon, no one could even think of financing a brand new mode of transportation. Another reason the railplane failed to take off was that other companies were afraid it was too efficient and that it would put them out of business. Between 1926 and 1929, Bennie repeatedly sought permission to build railplane tracks over Southern Railway's service between London and Brighton, but to no effect. In 1931, Bennie had raised enough money to build a 20-mile railway from Holborn to Croydon Airport, but was again rebuffed by Southern Railways, which was worried about the loss of revenue from their existing service to Croydon. But as government interest in the railplane grew, Southern Railway offered to build a line running from London Bridge to Dartford via Lewisham. Still, Bennie turned it down because he only wanted that line to the airport. Another investor, Henry Boot, proposed building two new towns at Waltham Abbey and Dagenham, both linked to central London by railplane, but this plan didn't get off the ground. With an ambivalent Southern Railway and few investors volunteering to support the transport system, the company Bennie set up to promote the railway ousted him from the firm in 1936. Having financed most of the project himself, sinking £150,000, which would be £5 million today, Bennie now found himself without anything to show for all of his hard work. By 1937, he sold his interest in the development company and was declared bankrupt. Experiments on the railplane prototype continued without his supervision, but never got far enough to be introduced into passenger transportation. Eventually, the project was abandoned, and the railplane track was demolished in 1941, with all known components being donated to wartime scrap metal campaigns. Bennie and the company he founded continued to work on new ways to promote the railplane, but the situation was financially dire. Not only did Bennie need help to get by, but at this point, he was living in shared housing. He again suggested a railplane link from the center of London to the airport, an idea which at this point became something of an obsession. In support of that obsession, in 1946, he founded the George Bennie Airspeed Railway, which was in turn followed by subsidiary companies. But by 1951, all of these ventures failed to deliver any results. The prototype railplane lay rusting in a field at Milngavie for decades. The car's once grand interior was gutted until it was sold for scrap and parts in 1956. Sadly, George Bennie died in a nursing home a year later, alone and in obscurity, at the age of 65 without a penny to his name, and his story has nearly been forgotten. Today, a 20-minute silent video of George Bennie's railplane can be found on the National Library of Scotland's website. Filmed in 1929 and 1930, it features the opening stretch of track and the railplane in motion. The original shed where the railplane car was built on Main Street is now occupied by a timber merchant and has a blue commemorative plaque on the outside wall. But George Bennie and his railplane still left a stamp on modern public transportation. You see, in 1947, the renowned French bridge builder Lucien Chadenson became interested in the Bennie Railplane project. He was also impressed by the Paris Metro Route 11, which began to use rubber tires in 1956. Chadenson combined the two ideas, resulting in a suspended monorail in which the bogies were protected from the weather by a steel or concrete box beam above the train. The test track made with this prototype operated for many years in the south of Paris. It was also featured in the film adaptation of Fahrenheit 451. Chadenson would lead further developments of the suspended monorail in the 60s, working with Safage, a French consortium. Safage would become one of the premier types of suspended monorail, later adopted by both Japan and the United States. Modern monorails are just catching up to Bennie's vision, with high-speed rail passenger trains traveling at over 120 miles per hour and cruising at over 200 miles per hour. HS2, a high-speed rail project in the UK, also plans to build a new monorail over existing railway service. 4 new Safage-style suspended railway prototypes have been developed since 2010. By 2016, China had created 3 lines, and to the north, in Russia, another prototype was also established. But beyond that, we are only left with this mind-boggling image of a futuristic concept from a bygone time. And we'll leave it there for today, but I thank you all for watching. Hope you'll consider subscribing. And until next time, I'm Ryan Socash, signing off.